Good afternoon, friends. I hope you are well and everything is okay. Okay, there is no problem during the communication. Today we are going to continue to project management, especially project management, especially the management of the implementation period of the engineering projects. It's very important for scheduling. Planning, scheduling, and implementation of the project is very important. It's very important to determine the duration of the project investment for investment projects. It's very important for determine the investment period. How long does it take? When will it be the earliest finish time of the projects? What kind of activities will be critical ones, etc. It's very important for implementation of the project. As you know, we know something about preparation of the appraisal of feasibility projects. It's okay, but let's assume that the project we prepared is feasible. Maybe we would like to know how long does it take to go on production of the production of the goods, for example. What will be the earliest earliest finish time of the project? What will be the latest finish time of the complete time of the project? How long does it take? It's very important. How can we manage anyway this kind of project structure? What kind of activities are very important for and critical for implement the project on time? What will be the cost of the project considering the resource restriction or limitation of the resources? How can we manage this kind of project considering the cost of the project, etc.? It means that we prepare the feasibility project, any project, for example, production of some part of the a car, for example, with a certain capacity. Okay, we evaluate it. We evaluate it. We prepare it. We make market analysis. We make economical analysis. We establish the technical process of the project. We determine the annual cost, fixed cost of the capital cost of the investment. Okay, we evaluate the operational period incomes and expenditures, annual expenditures, where we estimate the cash flow of the project for profit during the operational period. Then we evaluate it considering some project evaluation techniques, for example, net present value and break-even method, etc. Then we evaluate that our project is feasible. Net present value bigger than 0. It's okay. We can go on. Okay. It's okay. There is no problem. We can decide it to start to implement this project, but we wonder how long does it take during this investment period? How long does it take? What will be the what kind of activities we are going to encounter? how many activities will be should be realized during this implementation period. What kind of what is the relation between the activities? We have to learn something about the sequence of the activities. Which one is prior, the predecessor? Which one will be the successors? For this reason, we have to make a work structure breakdown. It's very important for project management. Work structure breakdown. We have to determine all kind of activities. We have to determine the sequence of activities. We have to determine the duration of the activities. For example, what's written in activities? For example, for a construction, it will be helpful for understand the system. We would like to construct a building. For this reason, we have lots of activities during this period. First of all, you have to prepare a project. Okay, it takes about 3 months, for example. Then you have to arrange the land if you need the land acquisition. Maybe it takes about 3 months. I don't know. Then you have to arrange some permits. We have to take some licenses. Maybe it takes 3 months. I don't know. Maybe you can start with at the same time for this kind of activities. Then you have to establish the mobilization status on site. Maybe then you have to start to organize the material logistics of the material, some contracts, management, etc. Cement, steel, bricks, etc. You have to manage something like this. Maybe you have to arrange something about the excavation of the foundation. Maybe it takes 6 months, for example. We could not start to the concrete application till the excavation of the foundation will become complete. Otherwise, you could not start, etc. Those are something about the activities. I think it will be clear. This kind of things we can say those are activities. We have to determine the activities, sequences of the activities in any times, and what kind of resources we need in any time of the project, for example. But first of all, we have to determine the activities, relation between the activities, precedent of any activity, the successor for any activities. But for example, a certain activity, what will be the earliest start point of any activity? What will be the latest start point of the time of any activity? How long does it take? What will be the duration? When it will be finished at the earliest time? When will it be finished the latest time, etc. We have to determine something like this. You have to in big projects. These kind of activities takes more than 1 million activities, 10 million activities. For example, construction of an Istanbul Grand Airport was consist of 10,000 million activities. The project management have to be consider this kind of things. For example, the construction of the subway construction takes about 10 years. There was lots of activities. The project manager have to manage properly this kind of activities on time, considering the materials and the other resources, etc. It's very important for this kind of operations. As it means, I think you have a project, you decided to, you evaluated your project, you decided to go on, but you don't know how long does it take. As I said you before, this is our cash flow chart. This is the investment period. We would like to go into production. We would like to implement this project. What we would like to determine when will it be we can produce the goods or items, etc. How long does it take? It's very important. 1 year, 3 years, 10 years, or 1 month, 2 months, 15 months, etc. What will be the implementation, the earliest and the latest complete time of the project? This is what will be the earliest starting point, what will be the earliest finish time of the project, what will be the latest starting point, what will be the latest complete finish time of the project, etc. For example, in TOG company, it takes about 6 or 7 years. We have to in this under maybe some resources will be limited or unlimited. There is no constriction, for example, depending on the construction availability of the construction of the limitations, or the project duration of the investment period of the project should be variable, as it's clear. There is no problem. We have to calculate this period. It's very important, considering your opportunities, labor opportunities, material opportunities, capital opportunities, machinery opportunities, and import-export opportunities. All kind of resources is very important for this time. Generally, we can assume that we haven't got any restriction, any limitation. We can use related labors at the same time, at any time. There is no labor. We can count the labors if we have opportunities. Generally, we have to solve the problem considering the considering that we haven't got any limitation, any restriction. But as you know, in real life, we have lots of restriction on the basis of the labors, materials, etc. For this season, the project cost maybe change. For further evaluation, maybe you can discuss this kind of things during your master education of the master degree or in professional life. What kind of problem we will encounter? But what shall we do for problem solution? What kind of methodology we have to use for investment project management? One of most important one is the critical path method. Is very important for project managers. There are a few softwares dealing the matter that as I said you before, you have to take some training dealing the matter. It will be helpful for you, for your further and for your professional life. In this slide, maybe we can discuss something about the problem. Especially the critical path method, very important. Project evaluation review technique, the other another one for new project. For example, we know that how long does the mobilization will take for a building construction. We know maybe 3 months, 4 months. But if we would like to decide to construct a building in the space, we don't know what time, what will be the duration of the mobilization, the duration of the concrete organization, etc. For this reason, we have to estimate probability. We have to take into consideration the probability of the duration of the period, this kind of thing. The other, when we estimate or consider the probability of the activities in the space, it means the problem solving technique will be the critical path method. It is similar. Don't worry about it. But we are going to learn something about the critical path method, calculation of the critical path. What's it mean? The float. What kind of how can we calculate the total flotation of the activities? How can we use this kind of opportunities, etc. First of all, we have to learn some symbols, some fundamentals dealing the projects, dealing the methods. In this symbols, critical path is a sequence of activities between a project start and finish that takes the longest time to complete. Critical path method is based on the mathematical calculations and it's used for scheduling project activities. It's okay. We have to, as I said before, it consists of the sequential activities from start to the end of the project. Many projects have only the critical path, one critical path. Some projects may have more than one critical path, depending on the flow logic used in the project, etc. Depending on the dimension of the project also. For this reason, generally we have to use critical path method in order to understand the system. The CPM is to construct a model of the project that include the followings. First of all, we have to determine the activities, as I said before, a list of all activities required to complete the project, typically categorized within a work breakdown structure. As I said before, work breakdown structure. It means you have to determine the first activities, second, 10, etc. relation between them, etc. We have to determine it. For this reason, you have to use expert knowledge of some experts on the basis of this project, depending on those project types, etc. You have established a team, implementation team, group, equipment, etc. You have to determine the activities, relation between the activities, etc. Duration, the time duration of any activities. It's very important. The dependencies between the activities, relation between the activities. You have to determine this kind of things. Then you can organize a network using this kind of opportunities. Then maybe you can calculate using some methodology. We always mention about activities, mention about events, mention about network, mention about dummy, Slack activity, etc. For this, we have to learn something about the terminology. It's very important. What's it mean activity? For example, activity, an activity carries the arrow symbols. This represents a task or sub-project that use time or resources. Generally, we can use nodes, and arrows. This is an activity. Activity A, for example. It can start with event I, and it can be finished, complete in activity G. It means activity A, starting from node I, and will be finished in node G. Node I and G are events. But AIG means this is an activity. Generally, you can write the duration. For example, 5 minutes. For example, 1 arrow, event 2, 4. It means this is the duration of your project, your activity. Month, week, year, depending on your acceptation. This is the dimension of the arrow is not so important. It's very important for the determine the relation between the activities. This is for the orientation. It's very important for orientation of the project. This is an activity. What's it mean? Event. A node that denoted by a circle. This is an event, for example. Mark the start and the completion of an activity. Starting event, completion event for this activity. This is an activity. We can use this kind of. Generally, I always use this demonstration. Is very important for us. I think, this is a demi. What's it mean? Demi activity. An activity which is used to maintain the predefined predecessors relationship only during the construction on the project network is called a dummy activity. Dummy activity is represented by a dotted arrow and does not consume any time. The duration of any dummy activity is 0. Don't forget it. The duration of this activity is 0. You can use it for it will be an opportunity for organizational network of the project. It will be helpful for you. You can use it to serve. It's very important for organize the relation between the activities. Those kind of things, parallel activities. There are two activities which being at the same event, and at the same event, these activities are called parallel activities. It's not so. It's not allowed. You could not demonstrate it like this. For example, E, I, G, A, B. This is forgotten. You could not use it. If you would like to use, you can use demi. Then you can use this kind of things if you need. these kind of things. Maybe we can discuss the matter later. The path is a series of adjacent activities leading from one event to another. Yes, this is a path. There are lots of paths in any project network, but the most important one is the critical path. You have to determine the critical path, critical activities, and critical path. Otherwise, your project will be delayed. A critical path is the sequence of critical activities that forms a continuous path between the start of the project and its completion. Maybe we can discuss something about the network diagram. There should be a node, starting node, EIG, finished one, completion one. Those are the successor one. This is the procedure one. Those activities, A and B activities, are predecessors of the activity C. B activities are predecessors of the activity C. The activity C could not start till those two ones will be finished. We have to finish these two ones. Then you could not. You can start to do the activity C. This is a relation. It means that, for example, I must finish before either B or C can start. It's called burst event. This is a burst event. Both A and B must finish. A and B must finish before activity C can start. It's called merge event. Merge event. Dangling event is not allowed. It's okay. It's another fundamental principle for demonstrate the network. This is very important. Maybe we can arrange it. If we always use this kind of the nodes, for example, 1, 2, 3, 4, 6, 7. This is demonstration of arrows and nodes. Okay. For example, activity A must finish before B can start. Oh, it's okay. Okay. Otherwise, we could not start. Activity A have to be finished. Otherwise, we could not start. Okay. Both A and C. Both A and C. Let's clear this one. Both A and C. Sorry. Both A and C must finish before D can start. Okay. Is it okay? It's clear. It's called dummy activity. We know that the activity D could not start till A and C finished. If you didn't, for example, you know it, we could not use dummy. Is this right or not? Activity D, for example, I can write it here, for example. activity A, activity B, okay, activity C, and activity D. Okay. We know that there are a relation between A, C, and D activities. A and C must finish before D can start. It's called if activity D, the procedures of the D are A and C. In this demonstration, it's not suitable because, as you know, activity B can start after A. Similarly, activity D can start at the end of C. But there isn't any relation between the activity D and activity A. If we use demi in this demonstration, yes, okay, activity could not be started till A and C finished. First of all, A and C have to be finished, then we can start to the activity D. I think it's clear that this is the fundamentals. For this system, we have to use demi activities. As I said you before, the duration of the demi activity is a 0. It's empty. It's an empty activity. This is the fundamental principle dealing the network establishment of the network of critical path method. There are a few symbols also. Forward pass. It's a calculation of the project. Forward pass. Backward pass. It's very important for determining the early starting, early finish time of the project. It's very important. This demonstration is very important for calculation of the latest starting and latest finish time of the activities and the project. It's very important, the early start, determining the early start and early finish time of the project. It's very calculation by moving forward through the network. You have to consider the maximum ones. For example, in this case, we have activity A, B, C, D. As you see, the activity D could not start till A, B, C, and all procedure activities have to be finished. Maybe it can be finished at 8 weeks later, 3 weeks later, 4 weeks later. We have to wait till A will be continue. It means it can be at least the early starting point of this activity will be the 80th week, for example. Otherwise, it could not start. This is a demonstration, and the maximum one we have to take this consideration. The backward pass calculation, you have to take the minimum consideration. It's very important for the latest start and latest finish time of the activities and the project also. Maybe we can discuss the matter later. This is the main concept. The float activity. The float activity is very important. The float of the activity. There are lots of very important parameters for project managers. Float activity for an activity is the difference between the earliest and the latest start time of earliest and the latest finish time of the activity. You can maybe if you have any time of the project, for example, we have lots of activities in this time. For example, at the point of the event I, we have A, B, C, D activities can be started, but we have some constriction, the labor constriction, for example, restrictions. We haven't got enough laborers. What shall we do in this case? What shall we do? Which activities have to be start? Which ones have to be postponed? We have to make a decision. It should be very important for managers. What shall we do at this time? For this system, we have to calculate the total float of the project. Total float of activities, and we have to take into consideration for the starting activity, for the start to any activity, the lowest float is very important. If one of our activities has zero float, it means we have to start to this one. That you could not postpone it, otherwise your project will be delayed. It's very important. You have to take these kind of things. It's very important for the making decision. There are a few steps for solving the problems. First step is make a forward pass through the network as follows. For each activity I beginning at the start node. Yes, okay. Early start time. The maximum of the earliest finish time of all activities immediately preceding activity I. This is 0 for an activity no predecessors. This is the earliest time in an activity can begin without violation of immediate procedure requirements. It's very important. For example, in this project, this is a small project. One, 2, 3, 4, 5. I equal 1, G equal 2. This activities hasn't got any predecessors, but this one has 2 predecessors. This one has 1 procedure, etc. It means this kind of things. The earliest finish time, the maximum of earliest finish time of all activities, immediately preceding activities. The earliest finish time equal to earliest starting time plus duration of the activity. It means earliest starting time at duration. Okay, D equal to duration of the activity. Yes, okay. The biggest one, earliest finish time equal this one. The project completion time is the maximum of the earliest finish time at the finish node. This is the finish node. This is starting node of the project. Maybe we have lots of the other nodes, etc. There is no problem. Step 2, make a backward pass. through the network of as follows. Move sequentially backwards from the finish node to the start node. It means you have to calculate, for example, another project. And don't forget the arrows. This is a project. Yes, okay. We can calculate the earliest time on this way. Earliest starting earliest finish time of the activities and earliest start finish time of the project. Then we can do the backward pass. We can calculate the latest one, earliest one, latest finish time, latest starting time, etc. Those are the calculation techniques. Maybe we are going to listen using a video. It's not so important. Those are the calculation steps. Step 2, you have to calculate the password backward pass for determine the finish and start, latest finish and latest start time of the activities and the project, etc. We have to select the minimum ones. The latest finish time minus time to duration. Latest finish time minus duration of the activity. It will be the formula. This is another formula for determining this kind of thing. Step 3. Then you have to calculate the float time for each activity. Yes, okay. Total float. You have to calculate the total float of any activity. It means you total float TF. For example, generally total float of activity IG. Total float of any activity. How can we calculate it? It means the latest start and early start. Difference between the latest start and early start. Difference between latest finished and earliest finished. You can calculate something like this. Maybe you can calculate total float equal to latest finish time of the latest finished minimum. Maybe we can write the minimum, the latest time of the activity minus earliest start time of the activities minus duration. This is general formula. Total float of any activities is equal to the minus. You have to select the minus ones because maybe you have lots of activities in any node. For this reason, you have to take the minimum ones. Equal to the latest final finish time of the activity minus early starting time of any activity and minus the duration of the activities. Those are there are one solution, the second one, third one. It's the same thing. Which one is easy? I don't know. Maybe you can it will be understand. You can understand anyway. A critical path is a path of activities from the start node to the finish node with zero float times, not only zero, the lowest ones, maybe, and sometimes any activities could not described by zero. Maybe they have a few float all activities, but it means that the lowest one is will be the critical one. And generally, the activities with the zero float will be the critical ones. It's general rule. This is an example. They construct the CPN network using the details below and determine the critical path. Those are the activities. You have to determine this is the work breakdown structure. This is the activities. This is the excavation of the foundation, logistics of the concrete, site organization, mobilization, masonry, plumbing, electricity, etc. Those are the activities. This is the immediate procedure. It means that activity B could not start till A finished. First of all, the activity A should be finished, then we can start to do B. In this demonstration, it means activity F could not be started before B and E finished. Those are the duration of the activity. Week or months, day, depending on your project title and the direction of the activities. You have to determine these ones. You have to know, etc. This is the network of the project. You have to establish a network considering the relation between the activities. But generally, as I said before, I always use the nodes. This is the first node. This is the second node. This is the third node. This is the nodes. Those are the nodes. This is a project network of the considering the establishment of the network organization of the project. It means that our project have 1, 2, 3, 4, 5, 6, 7 activities, but one of them is dummy activity, slake activity, etc. This is with dots. This is the starting point. This is the finish time of the project. How long does it take? The problem is how long does it take the completion time of the whole project? For whole project, for determining the whole completion time of the project, you have to calculate the earliest starting, early finish time of the activities, latest starting, latest finish time of the activities. Then you can calculate the whole project time. This is you can use some tables. Maybe you can use. There are a few problem-solving methodology. Maybe you can use this kind of tables. Maybe you can. I'm going to show the simple one. Then maybe you can use it. This is in this table. This is the activities. Those are the activities. Those are the duration. Generally, we can say the duration time. D. Yes. This is the activity. It takes about two months. The duration of the B is 3 months. Yes. This is the activity. It takes about two months. The duration of the B is 3 months, 3 weeks, etc. The earliest starting, earliest finished. You have to calculate this one. We don't know anything about it. The relation they have to. This is a complex one, but maybe I can give you the simple one. You have to calculate this one: earliest start, earliest finished, latest start, latest finished, slake, float. It means then you have to, this is, when you calculate it, this is those was the 0. Those are the critical ones. In this activity, when you calculate it, we have 12 weeks or months float. We can postpone it, for example, depending on the conditions. This is another problem solving techniques, but it's not so important. This is a critical way. Maybe we can calculate again. It's very important for project manager, useful at many stages of project management. Mathematically simple. Give critical dependent float time of the activities. Provide project documentation. Useful in monitoring cost, visual representation, etc. will be helpful for them. There are some limitations when you use critical path method. So we have to specify precedence relationship, especially in big projects, in the dimensional project. It's very important. It's very difficult to determine these kind of relations. For this reason, you have to lots experts dealing the matters. The activity time estimates are subjective and depend on the judgment. Maybe you can use the past experience or for example, construction of a wall. How long does it take? We have for example, we have a 10 square meter of the wall, brick wall, for example. How long does it take to construct it? Depending on the skills of the laborers and the other peoples, etc. But we know we have lots of experiments in the past. It's easy to, for example, when we ask anyone, they can say that it's easy to 3 hours. Maybe it's easy because we have lots of experience in the past. Experience in it's easy. But for example, in the wall construction of the masonry of on the space, we don't know how long does it take. We have to calculate, we have to estimate it. Can be more difficult to understand Gantt charts. The time need for tasks is not as clear as with Gantt charts, etc. Yes, I think it will be enough for understand the main principle of the creation of the CPM. Now I'd like to show another slide using this opportunity. Maybe it will be helpful for us. Then, sorry. Okay, let's listen another. I'd like to show another. Maybe we can say something about this project. As I said before, the most commonly used technique to scheduling construction. It will be helpful to understand the details. This is a demonstration of the project notes and arrows. In this case, as you know, A, B, C, D. Those are the activities. 0, 1, 2, 3, 4, 5 are the events. The events means starting, finishing of the activities. We can say something about the purpose of the critical, so some benefits. You have to, as I said before, identify each activity or task in your construction project or your engineering project. Organize the activity and sequence and the dependencies of the activities. What task occurs before another task begins? Task means activities. In this case, we can say tasks. It means activities. Lay out the network diagram. You have to establish the network diagram. Following step 1 and 2, you now have to detect all activities and their dependencies. You are ready to draw our critical path and analysis chart, also known as etc. Those are another demonstration of this organization. Those are description. This is some. Maybe we can discuss some tasks. Those are the event numbers. Those are the activities. Description of the activities. For example, start, excavate and pour footers, pour concrete foundation, erect rough wall and roof, install siding, install plumbing, install electricity, install wallboard, lay flooring, do interior painting, install interior fixtures, install gutters and dawn papers, do grading, landscaping, and finish. This is a typical construction project activities. As I said before, we can make details, lots of activities, more than 1 million, more than 100 million in big projects, more than 1 billion activities, depending on the time. And maybe the time that the investment time maybe take 10 years. You have to calculate in any time of the project, any stage of the project, any time. You have to calculate and to determine. You have to analyze this kind of things. Those are successors or predecessors. In this case, the immediate successors. Those one, for example, this one is the successor of this one. Maybe those are the predecessors for these ones. For example, this is the this kind of thing. You have to calculate. You have to make description of the activities similar this one. Then you have to complete each activity at the time, duration of the activities. You have to determine it. It's very important. Determine how long does it take, for example. Then you have to calculate the critical. You have to determine the critical path using some calculation methods. Forward pass or and backward pass will be the more important one. Yes, okay. I think it will be enough for understand the system. I'd like to summarize, then we can listen related video. It will be helpful for understand the system. When we establish the network, for example, it will be easy for understand the system. I'd like to show we have described 1, 2, 3, 4, 5, 6. Okay, this is the arrow 4 weeks. Yes, this is our project network, our project. Maybe we can use this demi activity. Maybe it will be helpful. It means the duration of this one is 0. This is the activity 1, 2. Activity 1, 2. The duration 4. Activity 1, 4, 1, 2, sorry. The duration 4. This is the description of this kind of things. Now, how shall we calculate what will be the early finish time of this project? The earliest completion time of the project, whole project. What shall we do? How can we calculate it? For example, this is 6 months. This is the duration of the project, week. The unit maybe will be hours, days, weeks, months, depending on your conditions. We force this for solving the problem. We have to establish. We have to create two boxes. 2 boxes for each event. 2 boxes for each event. We can create 2 boxes for each event. Then this one, the above boxes, the above part of the box will be the earliest. This one will be the latest time of the events. Earliest, latest. In general, we can accept that the early starting time of the first event will be 0. That's okay. It will be 0. Then we have to calculate the earliest finish time of earliest. This is the earliest starting time of the activity 1, 2 will be 0. What will be the earliest finish time of this activity? We have only one way. As you see, we come here only one way using this way. 0 plus 4, it means it can be finished at the end of 4th event, 4th day. It takes 4th. In this case, what will be the earliest finish time of activity 1, 3? 0, one way, we have only one way. 0 plus 2, 2. Okay. We are coming to this activity, with this event, but we have 1, 2. We have 1, 2. We have to this demonstration shows that these activities could not be finished till activity 1, 2, and 3, 4 have to be finished. Otherwise, we could not start these ones. This demonstration is very important. It means these activities are depending on this one and this one. Okay, it's very important. For this reason, we have 2 ways to come here. In this way, 2 plus 6, it means 8. We have 2 ways. In this way, 4 plus 0, 4. If we use this way, we need 4 days for starting this one. In this way, we have to wait 8 months, 8 weeks. All of them have to be finished. Otherwise, we could not. For this reason, we have to accept this one, the biggest one. Then, okay, Now we are coming up to this event 5. We have two ways to come here. One road is this, one path is this, the other path in this one. In this way, 4 plus 3 equals 7. We can take in the mind 7. In this way, 8 plus 5, it means 13. We have only two ones. The biggest one have to be accept. It means 13. Okay. Now we are coming to this event. In this event 6, we have two way also, this way and this way. Then we use this way, 8 plus 3 equal 11. In this way, 13 plus 4, it means 17. You have to take the biggest one. It means 17. Okay. In this way, we have only one. 17 plus 6, 23. Yes, we calculate the earliest finish time of this project will be 23 months, 23 days, 23 weeks, etc. We can start from now, for example, from the first of October. Then we have to you can finish it at the end of any time. You can calculate it depending on your project. You can give some deadlines. It's not so important. It means our project could be started, could be finished at earliest finish time of our project will be the 23 time minute or weeks, days, months, etc. This is the calculation of the forward pass. This calculation was namely forward pass calculation. It's very important for calculate the earliest starting and finish time of the activities and the earliest completion time of the project. Then we need what will be the latest finish time of the project. Generally we can accept that the earliest finish time of the project and latest will be the same. You can write it this one. Then we have to calculate the backward pass. Then we are coming here. We have only one. When we come to from 7 to 6, we have only one day. It means 23 minus. In this case, we have to use minus. Minuses, it's 17. Okay. Then we have to come to here. When we come to here, it means 17 minus 4. It means 13. It means 17 minus 4. It means 13. Okay. But then we would like to come here. We have two days. We have two paths. The first one this, the second one this. Then we come to here, 17 minus 3, 14. In this way, 13 minus 5, 8. We have to do the lowest one. It's very important for us. We have to take this one, 8. Will be 8. Then we come to here. We have only one. We have two ways. One way is this. The other one, this one. 13 minus 3. 13 minus 3. It means 12. In this way, 8 minus 0, 8. It means it should be 8. The lowest one have to be obtained. In this way, we have only one way. 8 minus 6, it means 2, because we haven't got any other path. Okay. But when we come to here, we have two ways, this way and this way. In this way, 8 minus 3, it means 4. 8 minus 2 minus, 2 minus 2, it means 0. Which one we have to take into consideration? The lowest one, 0. Yes, okay. Yes, now we know that our project is okay. This is the earliest starting, latest starting, earliest finished of this activity, latest finished of this activity. Okay. Okay. Is it clear or not? Dear friends, I think it's clear. I'm going to now we would like to how can we determine the critical path of this project? How can we? We don't know anything about the critical path. According to the previous formulation, I said you that, for example, let's calculate the total float of this activity 2.5. Activity 2.5. Let's calculate the total float of this activity. I said you the latest finish time of the project, the activity, minus earliest starting time of the activity, minus duration of the activity. It means 13 minus 3, it means 8, 9, minus 3, 6. It means the total flotation of this TF of activity 2-5 is equal 6. We have 6 float time. We can postpone it, for example. But let's calculate of TF of 4-6 activity. 4-6 this activity. What will be the formula? The latest finish time minus earliest finish time minus duration. 17 minus 8. 17 minus 8. What's it mean? 17 minus 8, 9, minus 3, 6. Okay. You can use something like this when for example, in this case, 2 minus 0 minus 2, it means the total flotation is 0. You can calculate something like this. It will be helpful for understand the system. I think then we have to determine when we determine the project critical path of the project. It means our critical path is this. Sorry, and this. Can calculate. You can arrange something like this. Maybe there should be some mistake. Don't worry about it. You can calculate it. It's very important for understand the system. Maybe we made a few mistakes. It's not so important for. I explain it in order to understand the next video. It will be helpful. The next video will be helpful for you. There are a few problem solution methods. Then we can arrange the related problems. Now let's listen. We have a video. it will be helpful for understand the system. It will be meaningful. Let's listen this kind of videos. Which one was?
Analysis. Our first port of call. In this video, we're going to continue.
I have a question, Hojam, before we start the video, if you don't mind.
Yes, okay.
For the final project, sorry, I didn't listen at the beginning of the class if you said so, but for the final project, like we have only final project, there is no final exam, right?
No, we have final exam. Next week we have a final exam on the basis of the multiple choice test. I'm going to give some information dealing matter, but your project will be the most important. Your participation of the course will be the most important grade. I'm going to give you details, but we have a official exam next week, maybe I think in the 13th of this.
It will be on Blackboard, right?
Yes. We have multiple choice online exam, but the most important grade will be on the basis of the your project presentation of your project and participation of your participation of the course together with your exam.
Will there be any presentation for the final?
We can discuss. We could not discuss the more than this explanation. I'm going to give some announcement to the via WhatsApp or via emails. Don't worry about it.
Okay. Thank you very much.
Yes. Some questions. I'm going to send you some example of questions, but as you 2 or 3 days before exam. But more questions will be on the basis of your project and on the basis of this critical path method, etc. Okay.
First port of call will be to look at early event times and late event times. We saw in the last video that an activity network can model a real-life project such as building a house. Often these projects have deadlines, which means activities starting and finishing on time is important to avoid missing that deadline. We're going to consider now early event times and late event times. The early event time is the earliest time we can arrive at an event before an activity.
I think there is a problem dealing the demonstration
activity or activities can start, and we we've seen this in action until 9 hours has passed. The box on the top gives C dependent on A, so we can't start B and C until A has been completed. The late event time is the latest time that we can leave an event without missing the deadline or extending the project. So let's look now at a typical question. We're told the activity network for a project is given opposite. The time in hours needed to complete each activity is shown in brackets. Early and late times are shown at each vertex. We're asked to calculate the values of W, X, Y, and Z. Okay, let's first define a network. A network is a weighted graph. And in this particular case, the weight now is the time in hours. So this right here is an activity. This is activity A, and activity A takes 3 hours. What we're going to look at now are the nodes or vertices. These here are the events. The box on the top gives us now the early event time. The box on the bottom gives us the late event time. Sometimes these will be side by side. So we'll have 0, 0. We will have 3.
As I said you before, this is a early starting, early finished, latest starting, latest finished of activity A. Duration is 3 months, 3 weeks, etc. This is a activity A. Activity B, for example, activity B will be start from at the end of third days. It can be finished at the end of 9th days, etc. This is the same, similar to as you see. I explained this kind of methodology using the forward pass and backward pass method.
3, we will have 7y. So you need to be cool with a different notation. So let's just have a look at this network. We can see that A relies on nothing. It's dependent on nothing. Therefore, we can start this from the source node, from the beginning. So this is the source node, and then we've got the sync node just here. So activity A takes 3 hours. That tells me now that the earliest time that we can start B and C is going to be 3 hours. So this now is my early event time. If we now consider B, B has a duration of 6 hours. That means that this event can't now start until 9 hours has passed. So I can't start D until at least 9 hours has passed. If we consider coming down this route right here, what we've got now is 4. So C takes 4 hours. So we can't start E and F until 7 hours has passed, as we need both A and C to have completed before we start E and F. We find now the early start time by completing what we call a forward pass or a forward scan. And that's what we're going to do here. So what we're going to do is look at the dependencies, and we're going to move forward. So I'm interested now in the top boxes. So if we consider now, the first value that we're going to look at is W. So we can see that A now goes into this event here. So B depends on A only. If we go this route, we can see that we can start D now after 9. D takes 2 hours. Now that means that the earliest time that we can start this activity here, so the early event time is going to be the 9 plus the 2. We've got no other dependencies. We can start D after 9 hours. It takes 2 hours. So the earliest time that we could start G is going to be now 9 plus 2, which is going to be 11. So W is equal to 11. Now, what we've got to consider is X. X is the early start time. But we've got now that it's dependent on G, it's dependent on H, and it's dependent on F. We need to consider the largest number. This is now telling me the earliest time that I can finish this project. So if I went down this route, we've got now G. We've already taken 11 hours to get to this event. The earliest time we can start is 11. So 11 plus 5 is 16. This one right here, if we want to go from using H now, we've got 9 and 4. That's 13. If we now consider what we've got here, we've got 7 and 4, which is 11. We have to take the largest number, which is going to be now 16. This cannot complete. The earliest time I can now get to this event right here is 16 hours. So we've got X is equal to 16. So what we've considered now is W, this value right here is 11. We can't start G until 11, which means we can't finish the project until now 16, or we can't get to this event just here before 16 hours has passed. So that's carrying out a forward scan. So we're finding the largest number to go in the top box. What we're now going to do is look at a back pass and find the lowest value, which is going to give us the last event time. So what we're going to do is work backwards. this early event time here, X, becomes the late event time, Z. So Z is also going to be 16. So what we want to do now is work backwards. We want to find the value of Y, and we want this value to be as small as possible. So if we went this way, what we'd have now is 12. If we come down here, 12 minus 1 is 11. So we can see by coming back down, we're going to have a value of Y of 11. That now is the lowest value. If I went this way, I'd end up now with 12. So what we're going to have here, Y is going to be equal to 11. So that is the late event time. Now, what this is saying now is the latest I can leave this event right here, this node or vertex, is after 11 hours to ensure that I don't delay this project. Because if we consider now, I do 1 hour, and that will allow me now to get to this vertex, and then I need 4 hours to complete H. So if I leave any later now than after 11 hours, this is not going to complete in 16 hours. So when we're carrying out the back pass, we need to find now the lowest number. On the forward pass, we needed the highest number. This time we need the lowest number. So what this is saying now here, we can start C after 3 hours. It's going to take 4 hours. The earliest time that we could finish this now is after 7 hours, but we've got up to 11 hours, for 11 or in total 11 hours to complete this. And that's going to give us something we call float, and we're going to look at that later. But we can start this. So I could start this as late now as 7 after 7 hours and still ensure that I didn't delay the project as I would get in now, and that would give us our late start, our late event time, but we needed to complete C before now or on the 11 hours to ensure that we don't miss our deadline. It seems now that we could start this at 12 to finish this, but remember now we've got that E and F are both dependent on C finishing, and that gives us now the 11. So that's an example of using a forward and back pass to find now the early and late event times. With this particular case, it's not as easy to see as we're just simply working out values. So let's look at another example now. The activity network for a project is given opposite. So I've put it just here. The time in days needed to complete each activity is shown in brackets. We need to calculate the early and late times at each vertex. Now, with this, the source node, we're always going to have 0, 0, okay? We'll have 0, 0 here. So let's consider now, and we need to think about the precedence here of the early event times. So what's the earliest now we can get to this event? Well, we're starting at 0. The only thing feeding into this event is the A, and that's going to be 8. So we can get now, the earliest time we can get to this is going to be 8. Let's now consider here, we're coming down this way. Now you can go through as you wish. I prefer to come here as we're going to consider dependencies later on. So we're starting now at 0. B takes 6 hours, so the earliest time that we could complete, and now B at this event, so the early event time is 6. And remember, we're working in days. Okay, what's the quickest now that I can get to this event right here? Well, I'm here at 8, D is going to take 7, so the earliest that I can complete now is after 15 hours. If we consider now C, we've only got the dependency here on A. So we've got now, we can start C after 8, that's going to be 9, so this is going to be 17. Okay, this now comes to our first decision to make.
Yes.
Remember, the dummy isn't actually an activity,
we have to use
and it now adds absolutely no weight. So this would add 0 hours. So what we're looking at now is this event. I is dependent on both D and F being completed. Now, I can finish D after 15. But if we consider I can't now start I until F has finished.
21.
We can't finish F until 21 hours because we can't start it until 17 has passed. So 17 plus the 4 on our forward pass is the largest number. So we can't start I until 21 hours has passed, as F wouldn't be completed. So this is our early event time. So I is sitting there waiting and waiting for 21 hours. It can't start after 15 as it's dependent now also on F. Okay, let's now come down here. Let's have a look at this one right here. We got E. E takes 5 hours. It can't start until 6 hours. 5 plus 6, that's going to give 11. So again, on the forward pass, we're filling out the top boxes with the early event times now, such that this tells me that both H and K cannot start until we've got to the 11-hour point just here. So let's now consider this vertex or node here. We need an early event time. What's the earliest time J can start? We've got 3 things to consider. I now can start I after 21 hours, so it would take 26 hours to complete I. If I consider D now, 15 hours is fed in here, which means that early event time now would be 15. 15 plus 5 is 20. So automatically I'm saying to myself, it's going to be at least 26. We now need to consider that H is also feeding into this event. 11 plus 8 means I can get to here in 19 hours. So 19 hours, 20 hours, 26 hours. So J cannot start until I is complete. So this is 26. Now, this is our sync node. If we consider that I could get here now in 16, so we've got 11 and 5, which is 16, but our early finish time just here, essentially the finishing of the project, it can't finish until 31 hours, as now we can't start J until 26 hours past, so that's going to be 31. So the early event time for the completion of this project is 31 hours. So it's going to take us now 31 hours minimum to complete this on time. So let's now look at going the other way and finding now the late event times. So the early event time becomes the late event time, and we go backwards. So this time we've considered the largest number, as we're looking at the earliest time each event can start given its dependency. So what I want to do is now work out the lowest number. I want the lowest number in each of these boxes. So if I consider going back this direction, I can see now that going from 31 and taking off 5 is going to give me 26 hours. Now, as we'll see later on, this denotes a critical activity. This tells me that J is a critical activity, as it needs to start here at 26 and it needs to finish at 31. So it needs to start on time, finish on time. There's no slack or leeway, or what we call float, on that one. And in a later video, we'll look at that. Now, what time can I put in this box here? Remember, this now is the latest that we can complete E. If I go this way, I'm at 26. Now, if I subtract 8, that's going to give me 26 minus the 8, which is going to give me 18. If I went this way, it would give me 26. We need to take the lowest number, so we're going to go up through J, down H, and that's going to give me 18. So what this tells me now is that E, activity E, can be started after 6 hours, but it doesn't need to be finished until 18 hours, and then we still wouldn't delay the project. So I could start this after 13 hours, finish it after 18, and I'd still be on time to complete now in this 31 days. We're working in days, aren't we? Yeah, days rather than hours. So what I've looked at is finding the lowest number. Now, this says that I can finish E after 18 hours, and that will not delay it. So let's look at getting back here. I've got 18. The only way back here now is for 5, so we're going to subtract that. So that's going to give me now 13. So what does that say? That tells me that I can start now B from the beginning. It takes me 6 hours to do B, and the latest I can finish it without delaying the project is 13 hours. So if you think I could sit idle for 7 hours and then complete B in the 6 hours, and we still wouldn't delay the project. Okay, let's now look at getting to this vertex here. We want now the lowest number. And we can see that going back up here is going to give 21. And again, that tells me that that's a critical event. So I, it's a critical event. And as stated, we will look at that later. Okay, I've now got a choice here. I can go to this event right here. Now, this value here is going to tell me that the latest time D can finish. I can either go this way, or I can go up to I and down the dummy. We can see either way, but it doesn't matter. We're going to have 21, or if I go that way, I've got 21. And remember, the dummy is 0. So if I come down, it's going to be 21. If I go that way, it's going to be 21. So we can now put 21. And that is the latest time that we can complete D without now delaying the project. So for example, if I finish D after 21 hours, then it would take me now 5 hours to do G, which would get me into 26, which would now get me into 31. If I finish D after 21, I need I, which is going to be 5 hours, 21, 5 hours. We're still not delaying it. So this is what we've got. Now, just a bit of a consideration before we move on. The float for D is simply 21 minus 7 minus 8. So that's going to give us a float of now what we're going to have. We're going to have 6 hours. So we could start this after 14. So it means I've got from 8 to 14 to play with. That's your float. Your float is now the late event time minus the early event time minus the duration of the activity. And again, we will look at that in depth in a second video. Okay, what's the quickest I can get back here? Well, quite clearly, we've got 4. That's for routine. We've got 21. 21 minus 4. That's going to give me 17. Okay. If we consider now here, we've got the 9, and that's going to be here. So we're going to end up now coming back with our 8, and we can see that the 8 is going to take us here. This will always be 0, and we could even go and find a critical path on this. I'll save that for a later video, but hopefully that makes sense. Now, I could have gone back this way, but as you can see, we're going to get a larger value. I had the choice of coming down here. I knew it's critical, or I could have come back here. Going back there wouldn't have been ideal. 21 minus 7 is 14. We want now the late event time to be as low as possible. So there we go. That's starting to look now, and this will lead us on to the critical path analysis. We're looking at early event times and late event times. So let's just do a running commentary of this. Now, we can start A at 0. It takes 8 hours. So the earliest now that we could start C is going to be after 8 hours. C is going to take 9 hours. So the earliest that we could finish C is going to be after 17 hours. The earliest we can start D is after 8 hours. It takes 7 hours. So the earliest that we can leave this vertex to start G is going to be now 15. So that's a consideration here. But we need to also, when we come up here, consider the multiple dependencies. I is dependent on D and F, which means that we have to take the larger value as we need F and D to be completed before I. So this is just working through your early start times or early event times and late event times. So in the next video, we'll go on to float, and then we will look at critical activities and critical paths. In the last video, we looked at early and late event, the early event time, and you will need to show this in your calculations. So for A, therefore I can sit and do nothing from day. The float here, we've got 14 minus 1 minus 7. 14 minus 1 minus 7 is going to give me 6. Therefore, I can sit and do nothing from day 7 in the last video, we looked at early and late. Back to this event right here. So I could start this as late as 12. So the yellow ones are not critical. The green ones are critical.
Yes, I think it will be. Sorry, it's a mistake. I could not. Yes, I think we are coming up to the end of this slide, this video. I think it will be enough. Now let's calculate the sorry. Let's calculate the float of this activities. For example, activity 2.5. Do you listen me? Could you listen me? Could you hearing me? Could you hear me? Yes, okay. Our activity 2.5. Let's calculate the late float time of this activity. I said that the latest finish time of this activity is 14. The earliest starting time of this activity is 7, and the duration is 1 day. 14 minus 7 minus 1. 14 minus 1, 13. 13 minus 7, it means 6. We have 6 days, 6 months, 6 weeks float. Then we can postpone this kind of method. For example, in this demonstration, we are at the end of this. We are at the point of the even 2. We have 2 activities can be started, can start in this time. We have 1, 2, 4, 2, 7, 2, 5 can start. But if we haven't got enough labor, for example, we have only 10 laborers, but each activity needs 10 people. We are restriction. We have some limitation. We have only 10 laborers. We have 2 activities. Each activity needs 10 laborers, 10 people. For this reason, we have to postpone one of them. The question is this: which one have to be postponed? Which activity have to be started? This is a question. For this reason, we have to calculate the total flotation of these activities. Total flotation of the 2.5 activity is 14 x minus 7 minus 1. It means 6 days. Total flotation of this 2.4 activity 2.4, it means 10 minus 7, it means 3. 3 minus 3, it means 0. It means that at the end of this is the critical one, is this 2.4 is the critical activity. For 2.5 is not so critical because we have a 6 month, 6 day slack time, float time. We can postpone it. But activity 2.4 hasn't got any float, any slack time. The float time is 0. For this reason, if we are limitation, we have some restriction on the basis of the labor. We first of all, you have to start with activity 2.5. We can use this kind of analysis for manage our implementation project during the project implementation of our engineering project. It will be helpful. It will be very successful for management of our project. CPM, as you know, CPM is a very useful project planning and scheduling method. We have to learn. During these courses, we discussed some fundamentals dealing the critical path method and path evaluation, difference between the evaluation project evaluation review technique, something like this. I think it will be enough for your further trainings during your professional life, it will be helpful for you. I think we are coming up to the end of this course, this semester. I think it will be helpful for understand the system. First of all, you learn something about project appraisal of the project, proposal, proposal, financial analysis, economical analysis, technical analysis of the project. I think you learn something about it. You present your papers. Maybe you are going to evaluate your project till final exam. Then you have to send me again the final version of your project. It will be taken into consideration for final grade. Then you'll learn something about the project management on the basis of scientific decision-making methodology, operational research methods, similar critical path method, Gantt chart diagram method, and project evaluation and review technique, etc. You'll learn some fundamentals dealing the matter. I think it will be enough for this season, for this semester. We can discuss the matter anyway. I'd like to give you some announcement in a few days dealing the financial final exam. Please check your WhatsApp and email addresses. I'm going to give you some exam questions, exam a few days later. It will be helpful for understand your test, multiple choice test method. It will be enough for you. Don't worry about your exam. It will be, but please check your notes, contents area, and please download some special videos dealing this course. It will be helpful for understand the system. I'd like to thank you. It will be helpful for you. I think it will be my great honor to be one of your lectures during this course. Maybe we can meet anyway face to face in faculty. I'll be there every Thursday. I'll be in the faculty. We can discuss. We can meet anyway. Have a good time. If you have any question, you can ask via WhatsApp, because I'm at another meeting. I'm too late. Have a good time. Congratulations for your attendance and for your final exam. Have a good time. Goodbye.